all swift swans. My team, or our team, were the swift swans, and we built a car crash severity predictor. And just a brief trailer. Forget my sharing the audio. Oops. Okay, I am. Cool stuff. Props to Atticus. He was the main force behind making the trailer. But yeah, so without further ado, I'll pass it on to, I think, Eric, to talk about, an intro to our project.
All right. Hey guys. Okay, so we made a car crash severity predictor. So essentially what I'm going to be talking about, and you'll hear me more later throughout this project, is I'm going to first talk about like introductions, what we were doing with this project and the history of our data set. So our data set is essentially just all the so our data set ranks every car crash in America from a scale of 1 to 4 on a severity scale. And essentially what we had to do for this project was we had to sample it down so that it wouldn't take about a week to run machine learning on it, because there was like 7 million something cases. And at the very end, we put together a few models, and yeah, you'll see later on. That's about it.
Yeah, so this is one of my graphs. So this is just a graph of all of the traffic incidents that was in the data set, categorized by year. So you can see like the steady increase up until 2023 because it hasn't ended yet. I think it ended around March where the data was taken. But yeah, it just keeps increasing with the reported data. Even in 2020, it's still pretty high. This is the severity of accidents over time. You can see the dip because of COVID, and then a huge resurgence right before 2021. And you can like see like several like events just happening in this graph. And here's the severity by like low, medium, high, and extreme. And those are just the 1, 2, 3, 4s. There were a ton of medium severity accidents. So if you get rid of them, this is what it actually looks like. This is the low, high, and extreme severities. These are the ones that are different from the mediums. Our data set had a ton of medium severities, or 2s. And later, when we were building our models, we had to filter all those 2s out because there were just so many. And here's the change based on the holiday. So the average day, it hovers, like close to Christmas Eve, Halloween, and New Year's Eve. Christmas Day and New Year's Day do dip because everyone's at home staying with their families.
Hey guys, I'm Max. This is an intuitive graph about top 20 30s with the most number of accidents. You can see, check whether your city is included. Miami, Houston, and Los Angeles really have a lot. And as expected, the cities with more people have more accidents. And the next graph is about the sum of accidents in all hours of day. And the rush hour during 7 to 8 and 17 to 18 has the most most number of accidents, and it's the most probably time which can happen. Yeah.
Although this is a heat map of mean accident severity across the states, and it's easy to visualize since it's, you can see the US, you can see the different states. So the more yellow colored, they have a higher severity, and the more like blue ones, they have a lower severity, mean average severity. So you can see like Georgia has the highest severity out of all of them, and like places like North Dakota have the lowest.
So this graph is a comparison between day and night incident counts, sorted by their severity level from 1 to 4. As the severity count rises from 2, the numbers of day night counts gets closer. Like for severity count 2, there's a huge difference between day and night, but if you look at 4, the difference is a lot smaller.
Okay, this is my graph. Essentially, you can see the severity numbers in the USA. And you can obviously see that like the highest amount of severity, like the largest amount of severity by count is a severity level of 2. And essentially what that implies is this will actually raise a problem for later. It's if a model essentially just keeps spam guessing 2, it would be right about 95 to 99% of the time. And so you would have to go with either undersampling or oversampling the data size, because you would just get a really inflated average accuracy score, and it's just not a good way to do it.
Okay, so Canius Neighbors is machine learning algorithm that's used for classification and regression, and it works by classifying each new case, I guess, based on how similar it is to other data that has like the closest data points. So it classifies it based on how similar it is to its neighbors and what those neighbors are classified as.
This is a random forest model. A random forest model is a machine, algorithm that generates multiple branches. And essentially it's if you go onto Google and like type up something like machine learning visual, it's pretty much the first thing that comes up, where you just have one thing and it branches off into 2 or 3 different things, and it just keeps branching. And essentially the computer will take like all these branches and make a logical call based on these branches and their outcomes.
The XGBoost model, it predicts it by creating multiple models and then getting the prediction of every one. And then so what it does is that compares each one, and it then it makes a decision based on like how well each one did. And so it gradually improves accuracy the more models it creates. Confusion matrix, it helps. It's like a visual thing. It helps you determine how well your AI or your algorithm is doing. And so if you see like one spot that's just completely bunched up together, you may want to start changing up your AI a little bit, because it's most likely faulted in a way.
And yeah, pretty much we ended up going with the KNN model, and because we had a 98% accuracy thanks to David's fine tuning. So let me pass it off to Ray. I think Ray will demo using the model for you guys.
All right, so yeah, I'm going to demonstrate our model as soon as it loads in. Sorry, it's being really slow. Hold on.
The replit turned off. I think that's why. I just restarted it.
Okay, okay, it's working now.
W.
Okay, so the severity is classified on 1 through 4, 1 being like low severity, 2 being medium, 3 being high, and 4 being extreme. So the first one I'm showing you, I believe, is level 1 severity.
Yeah, and while she's filling in the form, I'll talk about this model is trained just on California, because if we use the entire data set, of all of America, that'd take way too long. So
It also crashed the thing. It used more than 30 gigabytes of RAM. So when we were training it, it kept crashing, and it would take like half an hour to train. And then it crashes, and that was the worst part.
Yeah. Okay, so
still
this one
fun.
ended up being level 3. And then we have ones for the other severities as well. And so obviously the severity level it gives you varies based on the values you put in, but because 2 is severity level 2 is the most common one, if you just entered this empty, it would give you a 2. Because that's the most likely.
Yeah, and also the form just straight up has defaults. Like it defaults to just LA, because I mean that's the biggest city. It's California.
Yeah.
Precipitation 0, visibility is whatever. There are defaults. So if you don't have to put in every single field.
Yeah. Not every field is necessary in order to get an accurate severity level rating. So this is severity level 4. And then I'm just going to show you an empty one so you can see severity level 2 come up. All right, so severity level 2.
yeah, nice.
So yeah, that's our model.